Hello everyone, today we're going to be working on example 2-2, which is asking us to determine the magnitude of the resultant force acting on the screw eye and its direction measured clockwise from the x-axis. So to start off, what I like doing is I like finding this missing angle right here. And to find that missing angle, all that we're going to do is subtract these two given angles already from 180. And if we do that, that will give us 75 degrees. Next, what I like doing is I like drawing these two forces to the side because we're gonna draw a parallelogram with them. So now that we have our two forces drawn out, what we're gonna do is we're gonna take this force right here and we're gonna draw it exactly same on the other tip of the other resulting force. And then we're gonna do the same thing with the other with the other force. We're gonna draw this one. We're gonna draw it over here. And then by doing that, that gives us a parallelogram. So just so we don't get mixed up, we're going to draw out that this one right here is the 6 kilonewton. This one right here is 2 kilonewton. And this one right here is the same one from the other side, so 2 kilonewtons. And this one is 6 kilonewtons. Okay. So we know that this angle right here is this angle. So we know that this angle right here is 75 degrees, making us already know this angle, 75 degrees. So now what we have to do is we are going to try to find these two angles right here, which will be the same. We're going to call those beta. So how are we going to find beta? We know that the sum of a parallelogram is 360. So we're going to do 75 plus 75 plus, we have 2 beta, so 2 beta has to equal 300 degrees. So 75 plus 75 equals 150. Beta equals 360. That means 2 beta has to equal 210. And 210 divided that by 2, that equals 105. That means beta equals 105 degrees. It means these angles right here are of 105 degrees. Okay. So now that we have that information, we could find our resultant force using the cosine law. So using the cosine law and rewriting it just a bit, we end up getting this equation, which is f of r, which is our resultant force, is equal to f of 1 times, sorry, 1 squared plus f of 2 squared minus 2 times f of 1 times f of 2 times cosine beta. So f of r is our resultant force. F of 1 and f of 2 are the two forces already given to us, and we already found beta. All we're going to do is we're just going to plug that into the equation. So F of 1, we're just going to take that to be 6 kilonewtons squared, plus F of 2 is the 2 kilonewtons minus 2 times 6 times 2 times cosine. And we said that beta was 105, so 105 degrees. And now all we have to do is we have to input that into our calculator. And one key thing to remember is that when we're inputting this into our calculator, we want our calculator to be in degrees and not in radians, because if put in radians, it's going to give you a different answer. So square root of 6 squared plus 2 squared minus 2 times 6 times 2 times cosine of 105 should give you 6.7979 kilonewtons. And if you were to round that up, 6.8 kilonewtons. So right here, what we just did is we found the magnitude. This is the magnitude of a resultant force. This right here, the number we just found, is the magnitude of the resultant force. So this right here is our resultant force. And this resultant force has a magnitude of 6.8 kilonewtons. So we found the first part of our problem, but it's also asking us to find its direction measured clockwise from the x-axis. So the x-axis is right here, you can see, and it's asking us to find its direction clockwise, meaning in this direction. Counterclockwise would be finding it like this direction. So we're finding it clockwise. So how are we going to find it? So basically what we're trying to do is we're trying to find this angle right here. We'll call that angle B. We're going to call that B. So we're trying to find B right here. So what is V? How could we find V? Well, from the looks of it, V is equal to the 45 degrees that's already given to us, plus we're going to call this angle right here that's missing theta. So phi equals 45 degrees plus theta. Okay, so how do we find theta? To find theta, what we're going to do is we're going to use this parallelogram that we drew earlier on to find theta. So here we know that our resultant force is processed right in the middle of our two forces, like so, right? Okay, something like that. So what we're trying to find is we're trying to find this angle right here. So again, like I mentioned earlier, we're gonna use the sine law to find that. How are we gonna use the sine law? We could erase this. We no longer need this. What we're gonna do is we're gonna do sine of theta over. So theta is right here. Like we mentioned earlier, theta is right here. So sine theta. So what's the force that's on the opposite side of theta? Because as we know, sine is opposite over hypotenuse, right? So the opposite side of that is 6 kilonewtons. Okay. And then here we're going to use the resultant force. So we're going to do the resultant force, this one right here, that we found earlier. that is equal to 6.8. This one's 6.8 kilonewtons. So right here. So what's the theta opposite to that? What's the angle opposite to that? I'm sorry, what's the angle opposite to that? It's the 105. So sine of 105. Now all we gotta do here is just solve for theta. So what we're gonna do is we're gonna do sine theta is equal to, we're gonna move the 6 kilonewtons to the other side by multiplying it. So we end up getting 6 kilonewtons times sine of 105 over 6.8 kilonewtons. So we're going to input that into our calculator, once again, making sure that our calculator is in degrees. 6 times sine is 105 divided by 6.8, giving us sine of theta equals 0.85229. Okay, we're almost there. Now we just need to get theta by itself. So all we're going to do is we're just going to do theta was the sine inverse of what we just found. Sorry. Giving us theta is equal to 58.4616. So theta, if we were to round that out, is 58.5 degrees. So with that, that's how you find theta, but that's not the answer, as you guys remember. So what we're trying to do is we're trying to find phi. And we said that phi equals 45 plus theta. So there's still one more step to go. We're going to do phi is equal to 45 plus theta, which we found just a few seconds ago, which is 58.5 plus 58.5. So 58.5 plus 45 gives you a total of 103.5 degrees. And with that, we finish this problem. So once again, this is our resultant force. This right here, our resultant force. This is the magnitude of the resultant force, better said. That's the magnitude. And this is the direction clockwise from the positive x-axis. So once again, just to sum up, the magnitude of the resultant force, we got 6.8 kilonewtons, and the direction measured clockwise from the x-axis was 103.5 degrees.